Everything around you is made of elements, tiny building blocks with unique personalities. The periodic table is like a neighborhood map, organizing these elements by their properties. Some, like oxygen, are essential for life. Others, like gold, are prized for their beauty. But not all elements are friendly. Some are dangerous. Their danger comes in different forms: silent poisons, explosive reactions, or invisible energy that harms our cells. It all comes down to their atoms. Some are unstable, desperate to react or change. These unstable atoms can disrupt our bodies or react violently with their surroundings. In this video, we'll tour the periodic table's most hazardous residents. We'll explore three main groups: toxic, reactive, and radioactive elements. We'll look at specific examples and learn why they're so risky. It might sound scary, but it's also fascinating. Science is about understanding the world, including what to be careful with. Ready to meet the periodic table's most dangerous neighbors? Let's get started. First up are the toxic elements, the sneaky troublemakers. They don't explode or glow, but they can quietly wreak havoc inside our bodies. Toxic elements often mimic helpful ones, tricking our cells into letting them in. Mercury is a classic example. In the 1800s, hat makers used mercury and suffered severe health problems as it built up in their bodies. Mercury attaches to proteins, disrupting their function and damaging the nervous system. Lead is another notorious toxic element. It used to be everywhere, from paint to pipes. Lead mimics calcium, interfering with brain function, especially in children. Even small amounts can cause lasting harm. These elements look harmless, but inside us, they're biological wrecking balls. That's why there are strict rules about using mercury and lead today. Scientists learned the dangers the hard way by seeing the harm they caused. Toxic elements remind us that danger isn't always obvious. Sometimes it's slow and silent. Understanding them helps us protect ourselves and our environment. Let's look closer at a few of these toxic deceivers. Thallium is a soft, heavy metal that's incredibly poisonous. It closely resembles potassium, which our bodies need to function. When thallium sneaks in, it disrupts vital processes, causing a slow breakdown of the body. In the 1950s, thallium was used in rat poison, so dangerous it was eventually banned. Lead's story is just as alarming. The ancient Romans used it everywhere, and some believe widespread lead poisoning contributed to their empire's decline. Lead leached into food and water, causing health problems over generations. These stories show how toxic elements can masquerade as helpful ones, fooling our biology. Our bodies are complex machines. When a toxic imposter gets in, things fall apart. That's why we have safety rules to keep these elements out of our homes and food. Chemistry teaches us to spot the deceivers and stay safe. Now, meet the reactive elements, the periodic table's thrill seekers. Alkali metals like lithium, sodium, and potassium are desperate to react, thanks to a single lonely electron in their outer shell. They're so unstable, you'll never find them pure in nature. They've already reacted with something else. Sodium in your salt shaker is safe sodium chloride, not explosive metal. In labs, pure alkali metals are stored under oil to keep them from reacting with air. Cesium is a standout. It bursts into flames on contact with air and explodes in water. The reaction is instant, releasing a huge amount of energy. At the bottom of the column is francium, believed to be the most reactive of all. But francium is so rare and unstable, it vanishes almost as soon as it's created. Less than an ounce exists on Earth at any time. These elements show the raw power of chemistry, energy unleashed in a flash. Their reactivity makes them both fascinating and dangerous. Scientists handle them with extreme care. Let's move to the final, most mysterious group. Our last group is the radioactive elements, dangerous because of their unstable nuclei. As they decay, they emit radiation-invisible energy that can damage living cells. Alpha particles are especially dangerous if inhaled or swallowed. They act like tiny cannons inside the body. Polonium is a notorious alpha emitter, discovered by Marie Curie. Just a gram could kill millions if distributed properly. Polonium's danger is silent and invisible, making it one of the deadliest substances known. Even Marie Curie's daughter may have died from accidental exposure. Polonium is rare and usually man-made for specific uses. Radioactive elements remind us that some threats can't be seen or smelled. They're the silent assassins of the periodic table. Understanding them is crucial for safety. We've met the periodic table's most hazardous residents: toxic, reactive, and radioactive elements. Why study them? Because understanding danger helps us protect ourselves and use these elements wisely. Knowledge lets us set safety standards for water, air, and food. Even the most dangerous elements have uses. Radioactivity can treat cancer, and reactive metals power batteries. The key is respect and understanding. Science isn't about fear, it's about being smart and prepared. The periodic table is a map, showing both wonders and hazards. By learning about all its residents, we navigate the world more safely. Keep asking questions, keep exploring, and keep learning. Science is cool.